Hello everyone, our today's topic is nitrogen and its compounds. Personally, my favorite topic won't be much of a mess, but quite long one, so we'll divide it into different sessions. Now we start with nitrogen. What is nitrogen? Nitrogen, as we know, is a gas composed of 78% of air, right? Nitrogen is an element in group 5 of the periodic table, atomic number 7, so electronic configuration 2,5. Nitrogen is prepared by three ways. The first way and the most important way that they can ask you in the exams is thermal decomposition of ammonium nitrite. So without further ado, let's dive straight into it. Now, you don't decompose ammonium nitrite directly. No, you use sodium nitrite, a mixture of sodium nitrite and ammonium chloride. The mixture being called double decomposition. So sodium nitrite plus ammonium chloride, you mix them to form ammonium nitrite plus sodium chloride. So thermal decomposition of freshly prepared ammonium nitrite. Ammonium nitrite prepared by mixing sodium nitrite and ammonium chloride. This is the equation for the reaction here. No need to balance, already balanced equation, double decomposition reaction. After which, once you get the ammonium nitrite from the mixture, ammonium nitrite then decomposes to give nitrogen and water. The nitrogen gas prepared here is pure. So, if it is pure nitrogen gas is slightly less dense than air. Now, the physical properties of nitrogen are: one, it is colorless and odorless. It has no color and no smell, as we know. Slightly soluble in water. So, it slightly dissolves in water. What does that mean? Collected by, it is possible to collect nitrogen by over water method. The third property is slightly less dense than air. As we just said, pure nitrogen slightly less dense than air. Impure nitrogen is denser than air. Why? Because it is mixed with argon. So when nitrogen is mixed with argon, it becomes denser than air. But pure nitrogen is slightly less dense. So slightly less dense nitrogen can be collected by upward delivery. Now when nitrogen gas is required dry, you pass it through concentrated sulfuric 6 acid. Let's go to the setup. As we can see, sodium chloride, ammonium chloride plus sodium nitrite have been mixed in this solution. This will give you ammonium nitrite plus sodium chloride. Ammonium nitrite will decompose to give nitrogen and water. Nitrogen gas collected by over water method. As we know, this is a beehive shelf, and this, why, now they can ask you in an exam, why is this flask slanted downwards? One, this is to prevent the flowing back of, the sucking back of water, which would otherwise crack the flask. Now, heat is required in this reaction, in this setup. Heat must be required because you want to thermally decompose ammonium nitrite. So when you suck back water or condensed steam, that would crack the flask. Now, chemical properties of nitrogen. As you can see, it does not burn nor support combustion. No explanation to that, it is how it is. Reacts with metals, alkali and alkaline earth metals to form metal nitride. E.g. sodium plus nitrogen, sodium nitride. Magnesium plus nitrogen, magnesium nitride. So these are white solids which will be formed when you react them. Now, what happens when water is added to a metal nitride? For example, you reacted sodium with nitrogen, you got sodium nitrite. Now, since nitrogen, the atomic number is 2,5. What is its valency? Valency 3. Okay, the valency of nitrogen is valency 3. That's why sodium being valency 1, nitrogen being valency 3, you cross them, this will be sodium nitrite. Okay, so sodium nitrite has been formed. What happens when you dissolve sodium nitrite in water? A gas that changes red litmus paper blue is produced, or effervescence of a gas that changes red litmus paper to blue. Now, what is the meaning when a red litmus paper is changed to blue? That means that whatever is produced is basic. Now, which is the only basic gas in chemistry, in high school chemistry? It is ammonia. Okay, so what happens when magnesium nitrite, let's say sodium nitrite, is dissolved in water? What happens? Sodium hydroxide is formed and ammonia gas. Okay, if magnesium nitrite is dissolved in water, what happens? magnesium hydroxide is formed and ammonia gas. So they ask you what happens when a metal nitride is dissolved in water. The hydroxide is formed, the metal hydroxide is formed, and effervescence of a gas that changes red litmus paper to blue, which is ammonia. Now, what are the few uses of nitrogen gas? The first one is it is used in light bulbs to prevent oxidation of filament because it is inert. The light bulbs that we use here, nitrogen being inert. Why is nitrogen inert? Nitrogen is less reactive. It is very less reactive due to presence of triple covalent bonds. Now imagine if one covalent bond requires heat energy to break, two require even more. Now nitrogen having triple covalent bonds requires a lot of heat energy to break. That is what makes nitrogen unreactive or less reactive. That is why it is inert, hence it is used in light bulbs. Nitrogen cannot be oxidized very easily, okay? Manufacture of ammonia in the Haber process. Nitrogen combines with hydrogen in the ratio of 1:3 to form ammonia. Nitrogen combines with hydrogen in the ratio of 1:3 to form ammonia. Another use is used to fill empty oil tankers to prevent explosions. Again, why? It is less reactive. Presence of triple covalent bonds you can add here which require a lot of heat energy to break. Manufacture of fertilizers and explosives. Now nitrogen is used to manufacture ammonium nitrate. Ammonium nitrate is used as both a fertilizer and an explosive. Okay, so let's just come back and recap this reaction here. What is being mixed? Ammonium chloride is being mixed with sodium nitrite. Why? To take the chloride to this side and the nitrite to this side to form ammonium nitrite plus sodium chloride. The ammonium nitrite then undergoes decomposition to give nitrogen and water. Okay. Now the second method of delivery of preparation of nitrogen. So industrial preparation. What do we mean by industrial preparation? Industrial preparation we mean fractional distillation of liquefied air, the large scale manufacture. The flow chart will be shown, but let's just go through the points. So you purify the nitrogen to remove dust. How do you purify it? You either pass it through filters or electrostatic precipitators. So you removed dust particles. Dust particles are gone. You pass the dust-free air. You bubble it through sodium hydroxide solution to remove carbon dioxide. Right? Sodium hydroxide. You bubble it through sodium hydroxide, or instead of sodium hydroxide, you can use potassium hydroxide. You bubble it through either of the solutions to remove carbon dioxide, because carbon dioxide will react with sodium hydroxide to form sodium carbonate and water, or potassium hydroxide to form potassium carbonate and water. You then pass the CO2 free air. You reduce the temperature to 25 degrees to minus 25 degrees to remove water vapor as ice. As we know, water vapor condenses 0 degrees. So when it goes to minus 25 degrees, the water vapor is removed as ice. So the moisture also leaves the air. Now what are we left with? We are left with nitrogen, argon and oxygen, because carbon dioxide is out, dust particles are out and water vapor is out. So you condense the air at minus 200 degrees. What happens? You liquefy the air. Condense the air minus 200 degrees to liquefy the air. So the air turns into liquid. You then carry out fractional distillation at minus 200 degrees and you collect nitrogen at how many degrees? Minus 196 degrees Celsius. And if maybe you want argon and oxygen, argon collected at minus 186 degrees and oxygen collected at minus 183 degrees. So our last method of preparation will be separation from air. Let's just briefly go through it. So our last part in preparation of nitrogen is separation from air. So we discussed already two other methods, thermal decomposition of freshly prepared ammonium nitrate and fractional distillation of liquefied air. So our final method is separation from air. Now this is a tap here, okay? So if there is a tap, what are you letting in? You are letting in water. Now This was an empty flask with nothing. When the tap is closed, this is an empty flask only with air. Now when you are letting water in, you are expelling what? What are you expelling? You are expelling the air out. So the air leaves the aspirator when water comes in through the tap. So that's the first apparatus. You move on to the second one. You pass it through a solution. You bubble the air through a solution of potassium hydroxide or sodium hydroxide. Either of the two. Why? To absorb carbon dioxide. In short, which two solutions can you use to absorb carbon? You can even use three to absorb carbon dioxide. It is either potassium hydroxide, sodium hydroxide, or calcium hydroxide. So in this case, you use either potassium hydroxide or sodium hydroxide to absorb carbon dioxide. So once carbon dioxide has been absorbed, the air leaves again through the second flat bottom flask and it goes into the furnace. Now the furnace, what is a furnace? Furnace means a place where there is heat. What is found in the furnace to absorb oxygen? Any guesses? Of course, our good friend copper. So copper is found in the furnace. It reacts with oxygen to form copper plus oxygen to form copper 2 oxide. You balance it with 2 and 2. What is the observation here? If they bring for you this setup and ask you the observation in the furnace, what is the observation? The observation is that brown copper solid changes to black copper 2 oxide. The copper is brown, then it changes to black copper 2 oxide. Okay? So we expelled the air, we removed the carbon dioxide, right? And we removed the oxygen. What is left? What is left is nitrogen and argon. So we have bubbles of a gas here. Now which gas is this? This is nitrogen gas. But is this nitrogen gas pure or impure? I'm glad you asked. This nitrogen gas is, of course, it's impure. Why? Because there is no way we removed argon. We removed carbon dioxide, we removed oxygen. Did we remove argon? Not yet. So the impurity here is argon. So you're collecting nitrogen gas 78%, but the 0.97% impurity is argon. Which method of gas collection is this? Over water method, which we already discussed. So that's all we need to know about nitrogen.